Hi, this is Timon Sloane with the Open Networking Foundation. I'm the Vice President of Marketing and Ecosystem, and I'm really excited that today, as part of our broadband series of Spotlight, we're here with British Telecom. And I'm very pleased to say that Simon Fisher has been able to join us today. Simon is the principal architect for Access Networks with BT. He has a really rich history with BT, and he is also involved with BT's work with Openreach. And I'm sure you're going to learn more about that today, but that's a really interesting development over the last few years, where the broadband system is being separated out so that multiple ISPs can have access to access technologies. And that's what's called the wholesale model in the broadband space. So with that, Simon, please.
Okay, thank you, Timon. Thank you for the invite to come and speak today. Yes, I'm Simon Fisher. I sit in BT Technologies, and I'm primary principal access network architect consulting into Openreach. So yes, I've got a bit of a long and rich history over 31 years in access networks. So all the way through fiber optics. Ironically, I started in fiber optic PON systems, and then had a segue for 10 years into DSL systems, and now I'm back very firmly in the optical space. So yeah, it's interesting times for network operators, especially with software-defined networks and disaggregated hardware now under our microscopes for the benefits that could potentially offer us.
Well, terrific. Well, we're really anxious to hear what you have to share with us today. So if you would, maybe let's go into screen sharing mode and get started.
Okay, thank you. Okay, good afternoon, everybody. It's a pleasure to be here. My name's Simon Fisher, and I'm from BT Technology in the UK. I'm the principal architect for Access Networks, and I consult into Openreach, who run the UK access network for BT. My presentation today is going to be focused on giving you a view into an operator's world and the benefits that we see from disaggregated hardware and software-defined networks, and then to take you through, okay, we can see those benefits, but then the challenges to us to realize those, introduce those, how could we phase that, and the ultimate architecture would be aiming for to get the real true benefits out of that disaggregated world. I'm going to start off then by just giving you a quick insight into Openreach, because it's pretty unique in the way it operates. Openreach is a wholly owned subsidiary of British Telecom, and it was established in 2006 following a UK telecommunications strategic review by the network regulator, which agreed to create a separate division of BT with the purpose of providing all communication providers in the UK with equal access to BT's local access network and backhaul products. So unlike most other global operators around the world who own physical network and services, and the services being offered to the customers, Openreach's business model is very different. Openreach is essentially operating an open access network, and hence the name. Openreach is operating a physical network at layer 2 Ethernet products on an equivalent basis to communication providers who can then offer innovative products over the top of that platform. The Openreach network is built around approximately 1,000 Openreach handover points and offers an open active line access network carrying traffic between exchanges and end user premises. Each of those Openreach handover points hosts head-end equipment, OLTs, optical line termination head-ends, which consist of fiber to the cabinet technology transmission equipment and also fiber to the premises line cards on the access side, plus Ethernet layer 2 switching and physical Ethernet ports required to aggregate and hand over traffic to the CPs on the cable link side. So Openreach's estate currently uses OLTs from Huawei, ECI, Adver, and Nokia, and each of the OHPs will utilize several OLTs to serve the total number of customer premises in an exchange geographical catchment. Within that model, we have a range of technologies we use, key technologies, and we use those to build that access network. Although we present a common standard Ethernet interface at the exchange end and the customer premises or the end user premises, we have the freedom to use whatever range of technologies we need to make sure the performance and cost requirements are met. So on this slide, you can see a selection of the three key ones, really. Over the last 14 years, Openreach has been predominantly deploying fiber to the cabinet solutions to deliver its super fast and ultra fast products to customers across the UK. And it was a very fast network solution to roll out. And I think these days we've got over 98.9% coverage of those products in the UK. To date, approximately 95,000 active street cabinets or DSLAMs have been built, and this estate continues to grow to meet the physical connection requirements of the market and also bandwidth demands. However, over the last year, it's been incredibly exciting. Having started my career in passive optical networks, I now find I'm fully back in the fight again, because the main thrust of all of the new build in the UK by Openreach is fiber to the premises, a completely passive network, which is predominantly using GPON technology initially, but with all the hooks to smoothly evolve that to XGS-PON as the bandwidth and customer requirements demand. Currently, we've built that fiber to the premises platform past about 2.6 million premises. The plan is that we will have gone past 4 million by the end of this financial year. And the big target, which has been announced to the city here in the UK, is that we will aim to go past 20 million customer premises by the mid to late 2020s. The key technology, as I've said, is GPON. It's on a 32-way split optical network, and there are hooks in that to do the evolution to the 10 gig symmetric XGPON system as and when we need that. On the bottom of the slide, you'll also see point-to-point fiber delivery, which is predominantly used to serve our business markets customers and also for mobile network backhaul. And down the right-hand side, you can see the range of bandwidths that we provide in terms of products. In terms of that fixed access network, to summarize the Openreach world, Openreach offers an open access network. It's got, as we see it currently, 640 communication providers who connect to that network at our handover exchanges. And that connects those CPs to about 32 million homes and businesses and also the mobile network. And we employ a large range of technologies to meet the performance and cost requirements, providing services to premises in city centres and very rural environments. I mean, typically city centres, we've got very short reach transmission optics being used there. But when we go to the outlying areas, the more rural areas of the UK, we can be putting together solutions which have to reach 90 kilometres out from those serving points. And in all of those, we deal with any building scenario, and we need solutions for all of those. Currently, we're engaged with overbuilding, as I mentioned, the fibre to the cab network with fibre to the premises, and that clearly is a multi-billion-pound investment for us. And as part of that process, clearly we're continually reviewing our network architecture and evaluating new technologies and industry trends to ensure we are optimizing the build, both the build, the operations, and also the product performance. On the left-hand side of this slide, you'll see that our network is currently built using OLT chassis. And here's where we start to move into the world of SDN, really. Those OLT chassis predominantly come from Huawei and ECI and also Nokia. But on the bottom left corner of the screen, you'll see with the red ring around it, Adtran. Now, Adtran, we've awarded a contract to, and that was awarded, you'll have seen in the press probably back in May, I think it was, if not April this year. And that Adtran solution is really Openreach's first step into the world of disaggregated hardware and software-defined network architectures. Why are we primarily interested in that? Why are we making that move? Well, this slide, the access platform needs to support cost-effective evolution of technology, product, and service levels. And this slide highlights the promised benefits of SDN under the three main headings that any network operator is always going to give their attention to and looking to improve. The diagram on the right shows the current integrated OLT chassis model moving, evolving to this sort of disaggregated model that we're looking to pursue with Adtran. The smaller diagrams on the bottom of the right-hand side highlight one of the immediate problems that we're hoping SDN is going to help us address. And even though it seems obvious, these are the sort of real-world priority one business benefit pursuits that operators want to focus on. It highlights the challenge that when we were deploying FTTC, the monolithic OLT chassis was okay because it did typically serve about 40,000 premises per instance of hardware chassis. As we move into the FTTP world, this drops dramatically though. So each of those OLT chassis, if it was completely equipped with FTTP cards, could only serve approximately 7,000 premises, which drives the requirement for more CP links, more OLTs in our exchanges, more CP links driving cost into the CP. And clearly that's not desirable by us or the CPs. Moving to a leaf spine leaf architecture gives us almost for free increased levels of traffic aggregation. So all of a sudden that problem virtually disappears. And in the diagram, you can see CPs plugged into a leaf spine leaf architecture, which we'd used in some of our, typically in most of our exchanges, or if we're going into smaller exchanges, it may just be a leaf architecture. But that aggregation exists and makes the CP world of interconnect and ours of handoff that much easier. And the port densities of those leaf spine leaf boxes enable smoother scaling of head-end build to meet incremental growth, both physical connections and also bandwidth. So it's a lot easier for us to scale in a more CapEx controlled way. And importantly, the separation of the software control promises to make the hardware available from a wider supplier base, and hence the promise of commodity pricing and lower CapEx costs. That vendor interlock problem that every operator discusses is not completely gone, but it's a big step towards giving us more freedom as to where we buy that hardware from. Other benefits include reduced cycle time for new product introduction, and important for every network operator, the ability to not only introduce new generation equipment quickly, but also the ability to more quickly and easily retire and migrate off legacy equipment and legacy kit. Ultimately, however, once all of that updated build is done, the focus will inevitably move to operational costs and the things which are the greatest outlier for network operators today. And personally, I'm very excited by the benefits that could be unlocked by streaming telemetry and closed loop automation. And that automation goal is really the key to the major benefits that most operators are going to be eyeing. In the OLT chassis model, we can't see our OLTs. We can see our OLTs are controlled by vendor-specific EMSs, element manager systems, and then our OSS is complicated in terms of its development because it has to virtually speak to every single vendor-specific instance of element manager. That's highlighted more clearly, really, on this slide, the target SDN architecture and the challenges we face. So, the benefits on the previous slide, I think, have been discussed for many, many months, if not years, and we can all see that all of those are possible, but how close can we get to that promised land? And you'll notice I keep using the word promised because that is really the phase I think Openreach and many operators are in. We're trying to see how we can land the benefits that are offered on that previous slide. Many of the challenges for operators are to cost effectively introduce that SDN, and Openreach is now really now working with AdTran on that journey to explore and evaluate the cost and benefit levels that can be achieved. I suppose the key question for us currently is, the first base is to get to introducing SDN and disaggregated hardware for new build. If we can't solve that one, we aren't going any further. But clearly, as the diagram indicates here, it's no good if, for example, Openreach could only introduce that in the case of AdTran equipment. We've still got Huawei legacy, ECI legacy, and Nokia legacy, or it's like existing kit already out there. And the only way we can really get to the diagram on the right and all the benefits and have the benefit of very simplified OSS that's totally removed from the mix of technologies and complexities involved between it and providing a service and maintaining that service, is if we can get all of that equipment under the same platform. Now that may be that it's a slow burn and we have to wait for that existing and legacy kit to be end of life and it's eventually swapped out for new kit. But ultimately on this next diagram, you'll see under the heading of our ideal architecture, the diagram on the right shows that we are quite open to trying to introduce those legacy network elements and possibly those legacy EMSs, if it comes to that, to try and get them under that control to get that benefit of simplifying our OSS development. So as I said, this slide almost highlights Openreach's ideal architecture, which offers the ability to manage multi-vendor networks in the Openreach domain with an absolute focus on flexibility and cost, excuse me, cost of ownership. Service provision and management abstracted from the Openreach Access technology mix, which removes all of that complication and that long lead time to doing OSS developments and product introduction. But the need for flexibility is key here. We need to be able to swap out key functions not only in the software orchestrator, but also in the hardware, and both need to be done almost as easily as the other. So we don't want the risk of swapping vendor hardware interlock for software interlock. So all of those software modules, all of those hardware modules need to be designed on an architecture which makes them equally as easily to swap out. So we're not sure how close we can get to achieving this, but the essential initial element to all of this is common standard data models and interfaces. Really treating all of this as modules and black boxes, but as long as those Yang models and netconf interfaces and Yang models are common, we're a long way down the path of being able to achieve this modular swap out world. So for southbound interfaces, we're looking for native open southbound interfaces, netconf Yang, for new network physical devices. And for virtualized OLT white boxes, we're looking for Volta, essentially. And where we have to bring in legacy network elements, we will need to use vendor proprietary APIs. It's one of the things I'd probably want to change on the diagram on the right, if I did it again, was the solid blue line on the right-hand side, which shows the OSS and the dotted line immediately to its left, which show us using legacy EMSs into the orchestration and OSS level. Ideally, I think it's fair to say we wouldn't want to go down that route. The licensing and costing model of trying to integrate a legacy EMS into then an orchestration, an SDN controller, and then up into the OSS, almost from where we're standing now, is probably an obvious additional cost that an operator couldn't bear. Would want to talk directly to the network elements. In terms of northbound interfaces, we're looking for standard APIs. I think that's obviously pretty obvious, which would enable fast and flexible service definition. So in summary, I think it's fair to say that Openreach is operating an open access model. It's different from other global network operators, but a lot of what we're looking for will resonate with any network operator's model of how they're operating their network. There is always a mix of transmission technologies because of the multitude of scenarios network operators have to face, from geographies to buildings to physical connect, and the challenges of service performance that presents. But the stage that Openreach is at with software-defined networks is really we're evaluating it. We've signed a contract with ADVA, and we are committed to trying to introduce that SDN architecture with first customer connected probably within the next 12 months. How rapidly we progress or continue with that or embrace it, really we're going to pass through all the gates as we go. We've got to prove that yes, it does really deliver a reduction in hardware costs, and that comes down to how is this as an entire ecosystem going to be costed and licensed and managed. Simplifying cross-platform OSS, how easy is that for us to actually realize in a live platform? A phrase that I always love is like we're trying to re-engineer the wings of a plane in flight, and all the customers are still expecting the food to taste better, the music to sound better, and the service performance has got to continually improve while we're trying to upgrade something which is very real and live, and you can't afford to take any service down for any length of time. Faster introduction of service, we could see how we would do that, but it's pointless being able to do that on only 25% of your platform. You need to be able to do it for the vast majority, and again, that's bringing in that existing or possibly new equipment as we churn out the old over time onto that type of architecture. Smooth technology evolution, yeah, goes without saying. But the golden one for me and the exciting thing that I see at the end of the rainbow is closed loop automation. There's a whole other lecture on and talk on how we intend or can see using streaming telemetry, but there's an exciting world out there. But we need to bear in mind that we don't just want streaming telephony from active network devices in the end-to-end service provision network. We also need it off what is off the network, which is essentially 90% passive as we move forward into a brave new world or over the next 10 years. And so we need to bring our current operator techniques for test and diagnosing completely passive networks together with the world of streaming telemetry from active boxes to create very powerful tools that tells us which guys with which skills to dispatch with which kit to which locations in the network as and when service gets disturbed or we need to restore or incrementally grow bandwidth and service. But the key challenges, evolution to orchestration across existing and new supplier equipment to achieve those benefits is the bit we're wrestling with now. And we can see a path to doing it, but how quickly and how efficiently and effectively we can do that is really the journey we're on. But the key requirements, absolutely standardize open interfaces, and above all, end to end, we've got to guarantee carrier grade service reliability across all of this. Thank you for your time.
All right, Simon, that was great. Thank you so much. I really appreciate you sharing what's going on with BT and with Openreach. A couple of higher level questions occur to me, but I'd actually like to start with something specifically that you mentioned. In your architectural diagram, you said something about maybe if you were to have redone it, you would eliminate the EMS and talk directly to the network elements. And I guess I'm wondering, in that model, does the EMS remain on the side, or you actually start to end of life EMS?
Well, I think that is one of the key questions we are grappling with currently, because it's easy to draw on whiteboards lines that seamlessly integrate, even with common interfaces between orchestration and existing legacy interfaces. But at the end of the day, we've obviously got relationships with those existing suppliers, and I'm not saying they wouldn't, but obviously we need to go through the discussion of how willing they are to share certain key information to enable that ideal architecture to happen. And key things like simply licensing requirements. I mean, some operators and indeed Openreach it's common for suppliers to charge operators on a connection basis. So it's per use basis. So if we've got an EMS that is controlling X million premises of service, and then we try and we're being charged for that, if we then try and plug that into an orchestrator, how's the billing for the orchestrator going to work? Is that if that's going to work on a similar licensing model, then we're going to get charged twice for the same things. So clearly that's not going to work. So there's a whole commercial level of discussion to go on here, and all parties are obviously keen to make that work. But as we sit here currently, we haven't got into that discussion.
Right, that's interesting. Yeah, I think we're hearing that elsewhere and seeing that elsewhere. That as operators get into this disaggregated journey, licensing comes up because licensing has historically been structured so that a single integrated box, you get the hardware, you get the software, it's all packaged together. And as you break it apart, suddenly you really have to deal with all different new facets of how you think about licensing and lifecycle management for the entire system. So that's great. So I guess I'm curious, we're all shooting these videos from home now. We have this COVID pandemic and it's impacting all of us. And one of the things we've come to recognize, and the world's come to recognize, is that broadband's been more important now than ever, and we're all relying on it and working from home. I'm wondering if you're seeing direct impacts from a BT and Openreach perspective. I mean, is it forcing you to accelerate any plans, or pressures on your network, or things like that?
It's been incredibly interesting. I think when we first went into lockdown in the UK at the beginning of March, it's ages ago now, isn't it? All our core network engineers were desperately monitoring how we all knew we were going to get hit with massive increases of bandwidth across the core, downstream, upstream in the access. But absolutely, the network stood it. We were nowhere near exceeding the capacity of our core network and the access network in the very way Openreach builds it, which is unlike other network operators. We have to build to like 120% capacity of 100% take up due to and there's another talk as to exactly why we need to do that, but that is the way we build a network, because we have 640 CPs and we aggregate the take up of all of those. So it's unlike another network operator who may be going in hoping for 15-20% take up on the network. Openreach gets the aggregated take up of 640 service providers. So we build our network very rich and thick and big. But it's brought, since we've all gone, yeah, okay, the bandwidth capacity was okay, it didn't stretch us, we're all still standing and breathing. Attention's now switched into things like this that we're on now. Loads of people working from home. I've just given a presentation which lasted 15, 20 minutes. You don't want a dropout in downstream and upstream bandwidth. It has to be reliable. It has to work. You've got to deliver a service where the customer doesn't even bother what bandwidth they're getting. It just, whatever button they push and expect to happen, does happen. So yeah, from the architect's point of view, and obviously I circulate on the access architect, but I circulate with the core and the mobile and all the other architects techs in Openreach and BT. Yeah, sharing experiences of what the hot topics are between the domains has been very interesting over the last 3 months. But a carrier class service is what the customer expects, even if they're residential, certainly if they're business. And that service must not go down. It must not fail. I mean, even rebooting a residential domestic router, it creates all sorts of chatter on social media, which can be brand damaging. So all the kit needs to be as reliable as you can possibly make it.
Yeah, no, I think that, of course, all operators care so much about reliability, and maybe residential reliability is even more important than ever now. So, that maybe leads me to another thought that, you're clearly sort of embracing this SDN-based disaggregated model, which is fantastic. And we see Volta kind of appearing in your architectural diagrams. And for those who don't know, Volta is really disaggregating the OLT itself to use white box OLTs, and then to extract software capabilities into sort of a mini cloud that runs out in the CO. So, disaggregating even down into the OLT chassis domain. So, operators have all historically really looked to that, this quote, this single throat to choke, a single vendor who will make sure they take full responsibility for pulling it all together and work with all the subs and whatnot. So, but then you have disaggregation, where you're now taking it and breaking it into pieces, or even, as you mentioned, licensing it separately. So how, where is DT, and how is DT thinking about that single throat issue, and who takes responsibility for this next steps?
Well, you're right in what you say. I mean, for many years now, the operators' models have moved more towards more and more emphasis on more and more onus and ownership by the suppliers who provide their equipment, service level agreements, performance. I mean, to take it to an extreme, operators were moving into a world where they just wanted to unpack the boxes and plug them together. And to a certain extent, most operators weren't even doing that. That was contracted out as well. So it's I don't think I can underestimate the shift. I'm talking with other operators around the world, and not just Openreach, and not just Openreach. Is a major shift when the management, who ideally do want to know where to focus when something needs to be developed, or something's gone wrong, or something needs to be enhanced, they want that point contact to be able to ask the intelligent questions and get intelligent responses. This architecture moves us into a world where you could easily, we've got to navigate our way through it. So it's not the other extreme to that, whereby I've got a OLT leaf box from one vendor, I've got a spine from another, I've got a CP leaf from another. It goes up through SDN and orchestrators from more than one supplier, and every time you're just creating complexity. I mean, I did a model the other day which was comparing the OLT chassis, the number of OLT chassis network elements that our current management systems have to manage, compared to taking the SDN to the extreme. And if you compare apples with apples and like for like, the SDN world in the Openreach case would require us to manage 7 to 8 times more network elements in a software-defined network world than it does in our current world. And clearly, we're very happy with our current world because we know how it works, and when it breaks, we know how to put it right. But those benefits that I had on slide 3 or 4 are compelling. and we want to explore those. And if we can do that in a cost-effective way, we will certainly go down that path. So we will negotiate the problems of it's more complex and the management and commercial aspects of it if those benefits turn out to be within reach. So we will solve that. When that's just business as usual. We solve these things. But yeah, so it's a double-edged sword. On one side, you've got significantly much more management and individual boxes to manage, build, install, cable, fix, upgrade. But on the other side, the promise of reduced CapEx, reduced OpEx, closed loop automation. When we go to fix faults in the network, if you've got automated algorithms which are detecting, analyzing, and dispatching a man to fix it, that's a lot better than having 3 or 4 departments and handoffs between those departments with a week's dwell time in between each one, and you become an awful lot faster and efficient. So the benefits, I think, the problems are solvable. The benefits are compelling, and it's just how do we navigate that path?
Yeah, it's interesting. Well, so maybe as the last question, and it is somewhat related, is that you're working in this wholesale model, this Openreach model, and I'm wondering about as you look at your architecture. We have one other ONF members that happens, NBN from Australia, who also uses a similar wholesale model.
Yes.
And thinking about what we could do better, or our ecosystem and community could do for the SIBA and Volta projects to really adapt them and prepare them to serve the wholesale use case. Are there any things that for you come to mind that we could think about?
The key thing, so I come from an architectural background, and over the last 30 years, I've dealt with many layers of how to build and operate networks. And I always, with all of those layers, operational cost is key. So we need to be prioritizing those things which have a clear line of sight to reducing a network operator's operational costs, in-life costs, service provision, management, churn, equipment upgrade, customer churn, all of those things which dominate the profit and loss accounts of operators on any build of platform. And I think every time I get slightly confused or there's many options and there's loads of chatter, I always drag the discussion back to where's the operational benefit. And as I highlighted in my talk, getting the data models standardized and common, so I'm not going to different box suppliers and they're using different non-standard Yang models. Because there's a lesson I learned when I was doing when we were doing FTTP about 5-6 years ago, and one of the very hot topics with discussion was interoperability. The fact in the Openreach case and other operators, you've got a supply arrays OLT head end, and on that you can only use supply arrays optical network terminations. The desire was huge to allow you to use any supplier's ONT on any supplier's OLT, because it simplifies the operator's world tremendously at all levels of the supply chain and commercials. But at the end of the day, we had all these plug fests around the world. We had all of these things where people claimed, yeah, we've got interoperability with various suppliers' OLTs. But we got to the point where, yeah, you got interoperability up to 60% of the capability and functions on an ONT, but the other 40% are bespoke to that supplier. So that's not quite interoperable. And we must not fall into that trap, which is so easy to fall into with the interfaces and the data models we're looking at and the telemetry streaming, how that's going to work. Solutions we're looking at now, they must be standard and common data models and interfaces and protocols, because we can't afford different suppliers to be adding the juicy and whizzy bits that an operator needs just in their bespoke development bits, because it's just not going to fly. Everybody's going to die a death if that happens. But no, I think the benefits are compelling. The question is only how fast and easy is the journey to get there. And I don't think anybody knows the answer to that at this point because of outside factors, what we've just seen with COVID-19 lockdowns, resources availability, not just CapEx, but also field forces and skills and engineering capability. And that journey is going to be impacted by all of that. And I'm convinced we will proceed down that road, but how quickly, I couldn't say at this point.
Mm-hmm. Okay, well, terrific. Well, I really appreciate your time, Simon, today very much. It's great to get some insight into what BT is doing. I'm sure that our ecosystem is really, interested. And um, I'm also really interested to see this journey with, the wholesale model being applied to Volta. And, I think the ecosystem is going to be taking some steps along in that direction. So, if there are others out there who are interested in that space, please feel free to reach out to me and to you, to Simon, as part of our ecosystem. And I'm looking for good things and interesting things to come over the next year. All right, thank you.
Thank you. It's been a pleasure. Thank you.